Software that I've found very valuable for being able to typeset and type up and present information. Many people have ever heard of the package LaTeX. Alright, so this would be a good thing. I had some handouts that are coming in off the photocopier now. LaTeX was developed back in the 1970s. I mean, it's actually very old software. It was done by a guy named Donald Canute. And what he wanted to do was be able to type up his scientific papers and have them look decent. Kind of a novel idea. So back in the 1970s and the 1980s, we didn't really have graphical user interfaces to make things look nice. We had text editors. So LaTeX was based on the idea of you type it in a text editor, and then you kind of give it the programming commands to make the document look the way you want. So this is actually very nice for programmers. Maybe not for grandma to type up a letter, because grandma's not going to understand some of the syntax behind it. As soon as the handouts come, this will make a little more sense. But one of the first examples you can do of a LaTeX file is, let's see, if I type in max. I'm just using a program called Emacs to type in my document. You can use any text editor you want. Notepad, WordPad, there's a thing on the Mac called TextMate that's really nice to use. But to use LaTeX, all I've got to do is just start typing in information about my document. So what this first line is saying is I'm telling LaTeX what kind of document I want it to be. In this case, I want to make a letter, or I'm sorry, an article, like a scientific article. I want to use letter size paper, so this is US 8.5 by 11, and I want the standard font to be 12 point. This tells it that I want to use the Palatino font, and I want to use the AMS math symbols. So there's a number of different ways, a number of different conventions for typesetting math. I want to use the standard, that is the American Math Society, AMS. So we'll give it a title, tell it who the author is, and then I think we can start typing. And then basically we do a begin document. And eventually we'll have to have a matching end document. I tell it where I want to put the title page. So basically what we've got now is just a real basic document. And if I want to do it kind of the manual way, now that I have my text file created, I can go and I can run LaTeX on my program. And so what will happen here is it'll process my document and it'll write out this thing called the DVI file. And the DVI file is just a kind of intermediate format. Now we can do whatever we want to do with this DVI file. So So in this case, I want to make my DVI file turn into a PDF. And so I'll do DVI PDF, and now if I go and look at that file, we should see that I have an example.pdf file in my home directory. Thank you. Well, we can see kind of a few things that it did. It followed the rules for the standard format for a letter or for an article, where I'm going to have multiple sections and bold-faced everything the right way. It actually doesn't look all that bad, does it? We can keep on going with our example. So, that's really interesting. Yeah. So, one of the neat things we can do is, as we build up our paragraph and build up our documents, we can add subsections. And it'll just kind of fill things in. Anyone ever do a really long document in Word, and you have like references that go back and forth through your document? They work real well? They really don't. They really, really don't. One of the things we can do in LaTeX is we can give labels to things. And whenever I give a named label to something, I can refer to it just by saying, reference the name of this label. So for example, if I want to say this is not Bob, when I go to rebuild my LaTeX file now, the first time I run it, it doesn't show up there, and LaTeX says, I don't know what label that is. But the second time I run it, it'll be there. And part of that is because LaTeX doesn't go backwards when it looks for labels, it only goes forward. Good software written in the 1970s. Give it a break. But by doing this, it allows us to very quickly build up cross-references within our document. And it's never like Word, where inserting text will suddenly make them not right. As soon as I rebuild my document, all the labels get reprocessed and are always updated from this point forward, which is really, really very nice. Anybody ever use the equation editor in Word when you're trying to type in stuff? Is that a real nice tool to use? Yeah, it really is. The equation editor in LaTeX is really nice. It's one of the things that when people use Word, they say, we really wish it had the equation editor. So equations appear inside dollar signs, and they can appear right in the middle of your text. And so this is an inline equation. It's going to be typeset in the middle of the equation that I'm typing. So for example, if I were to render this text now, what we see is that LaTeX automatically set that line in, and it changed the font to be the standard mathematical typeset font that is used in all mathematical publications. What's really cool is, let's say that this was actually a quadratic equation. By using the caret symbol, it automatically knew that that was going to be 3x squared plus 3x plus 2. If it was something a little bit more complex, we can type settings to it, things like summations and products and integrals and all types of stuff. This is the inline equation, and so you see that it actually fits inside the borders of one line. And it will look good in the final document. But sometimes you want an equation to kind of stand out. And when you do that, you can say begin equation, I can give it a name. Now I can just type my text. I don't need the dollar sign. One thing we can do is when you want to use summations, you can use the sum operator. If you want to use fractions, you can use the frac operator. And you can reference name symbols like pi. And so what happens here is it typesets the equation in the most appropriate format. And in this case, it has the label that I've given it, and it's a numbered equation. So now I can refer to equation 1, equation 2, etc., etc. We'll see here that it actually did exactly what you wanted to do. And that's a nice looking format in this equation. And you could even stretch these things out. So for example, I've got this equation, and then we could say later on, what's nice is because it's in LaTeX, we can just copy and paste the text. And stretch out this equation. Oops. And you've probably seen these kind of things show up in math papers or computer science papers. And this is how they're making professional typeset equations. Again, like I say, we can go ahead and reference these things. Sometimes we get a syntax error, just like any programming language, you have to try to figure out what the syntax error was. And it says I have one too many of these things. So we can do this kind of nice mathematical typesetting all day long. That's pretty cool. Ever just want to type in a table when you're using Word and you have to like insert a table?